Welcome back to Trick Equals Treat. Picture this. A group of tourists travels to a beautiful city for the holidays. This city is famous for 6 magnificent towers, which we'll call A, B, C, D, E, and F. But here's the spooky part. After wandering around taking selfies, every single tourist realizes something bizarre. From their current standing positions, they can clearly see towers A, B, C, and D. But towers E and F have completely vanished from sight. Wait! Giant buildings don't just disappear. So, what's the logic riddle here? Let's lay down the rules of this visual math puzzle. Rule 1. The tourists and the towers are all just distinct single dots on a giant flat plane, and nobody's sharing the exact same spot. No piggybacking. Rule 2. No 3 towers are perfectly lined up in a row, so no collinear funny business. Rule 3. The only way a view is blocked is by a geometric eclipse. A tourist can't see a tower if another tower is standing perfectly in the middle of their line of sight. So here is the ultimate question for you. Under these exact rules, what is the maximum possible number of tourists in this travel group? I've left all the rules right here on the screen for you. Pause the video, grab a piece of paper, and see if you can crack it. Ready? Let's break it down. All right, let's play detective. Since no 3 towers are in a straight line, the only way Tower E and Tower F can both be hidden from a tourist is if 2 different towers from the visible squad, A, B, C, or D, are blocking them. Let's look at Tourist 1. Imagine a tourist, Mr. P, is trying to solve this. If his view of Tower F is blocked by Tower A, and his view of Tower E is blocked by Tower B, he must be standing precisely at the intersection point of the FA extension line and the EB extension line. Let's mark the exact spot. Now, you might be thinking, could Mr. P stand at a different intersection, like where EA and FB cross? The answer is a big, fat no. Why? Because at that other spot, there wouldn't be a tower in the right place to block his line of sight to both E and F. There is only one magical point where Tower E and Tower F will be perfectly blocked by Tower A and Tower B at the same time. Anywhere else, the illusion shatters. So, the math trick boils down to this. Every pair of visible blocking towers creates exactly one unique hiding spot for a tourist. Since we know the tourist's positions do not coincide, they aren't standing on each other's toes. Our geometry puzzle just magically transformed into a combinatorics problem. We just need to find out how many subsets of 2 towers we can make from our 4 visible towers, A, B, C, and D. In mathematics, this is 4 choose 2, which equals exactly 6. That means there can be at most 6 tourists in the group. That's right. We can even map out all 6 epic hiding spots. Tourist 1 at point P uses towers A and B to block the view. Tourist 2 at point Q uses towers A and C. Tourist 3 at point R uses towers A and D. Tourist 4 at point S uses towers B and C. Tourist 5 at point T uses towers B and D. And Tourist 6 at point U uses towers C and D. Boom! Problem solved. Mathematics to the rescue. If you loved this logic riddle and want more fun problem-solving tricks, smash that like button, subscribe to Trick Equals Treat, and let me know in the comments if you figured out the answer before I did. Until next time, keep your angles sharp and your logic sharper. Bye, guys! Trick equals treat.